This video discusses how to find the vertex of a parabola. So in the previous section, we learned about what was called vertex form. And when the quadratic equation is in vertex form, we don't have to do any work. We can just look at the equation and identify the vertex pretty easily. So when it's in this form here, so you might have a number in front of the parenthesis, a number inside parentheses with an x, a squared on the outside, and then some number being added or subtracted. Then the number inside the parenthesis with the x, you're going to do the opposite of that, and then take the number here, and that would get you your vertex. Okay, so let's go ahead and review something that we've already talked about. So if we look at the number inside the parenthesis with the x, we're going to take the opposite of the -4, so 4, and then 3. And that would be the vertex for this parabola. So remember, the vertex is either the very bottom of the parabola or the very top of the parabola. So that's what we're finding right now. The vertex here, the number inside with the parenthesis, opposite of that is -3, and then there's no number here being added or subtracted, so it's 0. And then over here, the opposite of a -1 would be a 1, and then -5. So that is how you find the vertex if it is given to you in vertex form. But our topic today is how to find the vertex if it's in what we call standard form. So we cannot just look at it and know the vertex when it has this term in the way. So when it has the b term, so in other words, it's in y equals ax squared plus bx plus c. So we have that term that just has an x. So if you take a look at, for example, number 4, it has that x term. And if we look at number 6, it has that x term. But number 5 does not. So technically we would not have to do this work for number 5. We could just look at it. We'll talk about it when we get to number 5. So let's discuss how to find the vertex if it's in standard form and not vertex form. So the first step is to find the x value. So when we find the vertex, we always know when we write an ordered pair, x comes first and then y. So to find that number that goes here, you're going to use the formula -b. So to find x, you'll do -b over 2a. And this should sound very familiar to you, and you shouldn't be stressed out that you have to memorize one more thing, because if we look at our quadratic formula from a previous lesson, it looks very familiar because right here we see -b over 2a. So when you do the whole formula, it solves for x when the equation equals 0. And when you just do -b over 2a, this part gets you the vertex x value. So just that part of the quadratic formula. So let's go ahead and do that. To find the x value in the ordered pair here, so we know that a is the number in front of x squared, so if there's no number, it's a 1. And then we have b and we have c. So we're going to do -b, and so b is -8, over 2a. And then the opposite of -8 is +8, and 8 divided by 2 is 4. So we just found the vertex of the parabola, the x value. Okay, so again, this is just the non-radical part of the quadratic formula. So that's why you shouldn't be worried that you have to memorize another formula, because you have to memorize the quadratic formula anyways, and it's just this part of it. Okay, so then after we find x, we have to find y. So once you have x, to find y, we're just going to substitute that value you got for x into the problem. So this was step 1. And then step 2, you're going to take your original equation, and to find y, we're just going to replace the x with the 4. And now we are going to evaluate this. Order of operations, exponents first. So 4 squared is 16. Then we do multiplication. and then we're going to add and subtract, and we get -4. So what we just found was the vertex of this parabola here. So if we put in this function, y equals x squared minus 8x plus 12 into our graphing calculator, and we graph it, we can see that this does work. That our vertex here, the very bottom point of our graph, is at 4 and then down 4. So that is what we just found algebraically, and I just verified it by graphing it. Okay, so let's go ahead and take a look at number 5. So if I want to find the vertex, step 1, we use this formula. X equals -b over 2a. So when we look at the equation we're given, the number in front of x, there is not one, so it's a 0. So if I write this in standard form, so remember, standard form has ax squared plus bx plus c. It has 3 parts. So I just gave it 3 parts now, 3 terms. And so a is the number in front of the x squared, b is always the number in front of x, and c is the constant. So when I plug in b, it's 0, and then a is 1, and we get 0 divided by 2 is 0. So we just found that the vertex x value is 0. And then step 2, we take our original equation, so y equals x squared minus 4, and we take that number we just found for x right here, and we plug it in. So we would get 0 squared is 0, and 0 minus 4 is -4. So we just found our vertex is at 0, -4. So then if we take our graphing calculator, and we type in that function there, y equals x squared minus 4, and you can see that the vertex is at 0, -4. So because this one had a b value of 0, since there was no x term here, we didn't actually need to do this work. We could just look at it, and we can see that we could put it into vertex form like this. Y equals x squared minus 4. So there is no number in the parenthesis with x, so 0, and then this number here is the y value of the vertex. So technically didn't need to show work, but the work always works here. Okay, so we only have to show work when there is an x term. So for example, like this problem here, we can't just look at it and identify the vertex. We have to do work on these 2 problems. All right, so let's go ahead and find x. We're going to do -b over 2a. So remember, a is the number in front of x squared, b is the number in front of x, and c is the constant. So in this case, there is not one, it's 0. So we would have -b over 2a, and we could leave it as -3/2, or if we write it as a decimal, it's -1.5, or if you write it as a mixed number, it's -1.5. Okay, so then step 2, we take our original equation, and we're going to replace the x with -3/2 or -1.5. I wouldn't use a mixed number because that just, you can't, when we multiply, it has to be a decimal or an improper fraction. So I would pick one of these and go ahead and plug it in. So I'm going to go ahead and plug in the decimal, -1.5. And then we're going to go ahead and plug that into our calculator. So we have a negative, so we need parentheses, -1.5 squared, and then plus 3 times -1.5. And we would get that y is -2.25. Now, if you leave your answer as a fraction, you don't want to have one a fraction, one a decimal. That looks weird. We always leave it in the same. So then I can click the FD button, the second FD button. And so one answer I could have is -1/2, -2 1/4. That would be the answer with mixed numbers. And then I can change it to improper and write my answer like this. So these two answers are both good. Or as a decimal, I can have -1.5, -2.25. So all three of these answers would be excellent unless the directions said we had to leave it as a decimal or in fraction form. So that's how you find the vertex if it is in standard form. Again, we would not have to do any of this work for problems like this because they are in vertex form. You can just look at it and identify that low point or that high point, the max or the min. But on these ones, since they were not in that parenthesis form, the vertex form, we had to show our work to get the vertex.